So this is the G4 reflection, and there's a video lesson, and what we're going to do now is we're going to go backwards. So before, I would give you an X or Z value, and you would calculate a probability. Now we need to go backwards. So one of the important things is setting up your staplets. So you want to make sure you have normal distributions. Let me slide this over just a touch. Just a touch so you can see it better. There we go. So if you're doing z-scores, let's make a note to ourselves. If we're working with z-scores, actually, let me go ahead and copy the question since I'm here. Control-C, there we go. And so what is the value that cuts off the top 10% of the normal distribution? So what that means is if you're working with z-scores, use a mean of 0 and a standard deviation, of 1. So that's how you set up your model. So you're going to be doing Staplet. And the other thing is, if finding values, make sure to pick the right drop-down in Staplet. And I'll show you. I might modify my sentence there in a second. All right. So first of all is you have 0 and 1 because we're doing z-scores. So see how it goes 0, 1, 2, 3, 0, -1, -2, -3. So it looks like the empirical rule. That's what a z-score should look like. Now, one of the important things is there's two options. You want to calculate a value. So let me go ahead and snapshot that. That is the option. So make sure, here, let me just paste it in here. So that's the option you want. All right. So top 10% of the distribution, how do we set it? So we want right area. So it's going to be right tail. And the area is 10%. So it's 0.10. Hit calculate value. Let me show labels on plot. And that is pretty much your answer right there, 1.2816. So with the Staplet, this is easy peasy. And it shows, actually it shows it up there, so I don't need to get it down there. Copy. And then we'll put the answer over here for those of you who like to look at something. Boom. All right. Let me zoom this out just a touch. Perfect. Okay. So we can see that the answer is, in this case, the answer is 1.286. 816. And there might be some rounding stuff going on and things like that. So that's right there. So it gives it to you in this area right there. Okay. So let's go change that to 1.2. That's roughly that area. What is the z-value that cuts off the bottom 20%? So if using bottom, and I'm not going to worry so much about adding notes, we're doing left area and change it to 0.2 and calculate value. And you can see it's negative 0.8416. So let me go ahead and put negative 0.84. If it's below average, it should be a negative z-score. All right, so let's write ourselves a note about that. If the values are below average, above average, your z-score should be positive. If below average, it should be negative, right? So I don't really need to, I think, catch that next one. And then 50% of the curve is within how many standard deviations? So let's do this one. This one's a more challenging one. All right, so I don't think you need me to do problem 2 there. All right, so I think this is, okay, 50% of the curve. So what we need to do is basically set middle or central area. So what we're going to do, central area, because this is an option, and you want 50%, 0.5, calculate values, and there you go. So let me go ahead and capture this on Z-scores. There it is. So let me move you out of the way. There we go. And move you. So you want set central area. Actually, let me get that bottom setting because that's going to make it easier for you. Let me go get that. So I wanted to get this piece down here where it shows the setting. So I'll start here, right there. Copy. And it's nice if you set that show labels. It really helps. So there we go. So here we have, they're trying to figure out how many standard deviations. Set central area to 0.50. All right. And then use the positive Z because there are two Z's answers, right? Two Z boundaries. So just use the positive one, which is, answer is 0.6745. And we'll go and check that. And there it is. Okay. And then apparently I have a walkthrough on how to do values from normal probabilities using Staplets. So there you go. A soft drink machine should be regulated so that it discharges an average of X ounces per cup. The ounces of fill are normally distributed with the standard deviation of 0.4 ounces. What value should X be set at so that 98% of 6 ounce cups do not overflow? So I'm going to put that problem here. Come on, text box. All right, so now we're going to do another normal distribution. All right, I'm going to put this here. So I need to make sure standard deviation of 4 ounces, right? So I'm going to see if that works. And 98% of 6 ounce cups do not overflow. Okay, so this one's a little bit tricky because I don't have a mean, right? The ounces of fill are, so we're trying to set the mean. We're trying to find the mean. All right, so what we're going to have to do is we're actually going to have to use a Z-score, all right? Why? So, because we don't know the mean. We will have to use Z-scores because we don't know the mean. All right, and then, so let's go ahead and find out. Go back to the normal distribution. We're still on 0 and 1. And what do we want? We want 98% of 6 ounce cups will not overflow. So we're trying to find the boundary so for the lower 98%. All right. Try and find the Z-score. AKA the top 2%, depending how you look at it, right? All right, so let's find the Z-score for that. So for the Z-score, we're going to do left area if you like, and put 0.98. And you find that Z is 2.0537. So 98% of the cups will be below this thing. All right, so let me go ahead and get this. So that Z-score is what we need. This is a harder problem. Believe it or not, my AP kids will have trouble with this problem. Some of them still are learning how to do it. In fact, they have a quiz on this today, a skills quiz. They have to do it very quick. They have to do these problems in like 2 minutes. All right, so what we found out is Z is that. Now what? Well, what we're going to do is we're going to use our formula, all right? Value equals mean plus Z times SD. All right, so we know we want 6 ounce cups. We don't know the mean, that's an unknown, but we do know the Z is 2.0537, and we do know the standard deviation is 0.4 ounces. So 6 equals the mean plus, and let me go ahead and Google math that for a second. Luckily, I can do it this way, since I don't have a calculator on me, and that's not a trivial number. Let's try that again. Let me change it 2 times. There we go. And there's my number. All right, so we'll go put that in my scratch work. See, there we go. All right, so then we subtract that from both sides. So let me go back to my calculator. I'm going to go backwards. It's going to give me a negative because I'm going in the wrong order. 5.18. So what I did is subtract from both sides. And then we get 5.18 roughly is the mean. All right, so that's where I should set my mean. That should be 5.18 ounces, so that is 6 ounces. So that was a little bit more work than you're used to. Let me see if I can put all this here so I don't use up so much space. There we go. Yeah, we're running low on room. Okay, so let me go. Hopefully there's something like 5. Oh, look, 5.18. And we'll submit our answers. I hope I got all these right. Yay. All right. Using the empirical rule, so now we have, oh, by the way, you can roughly use, the nice part is you can use this on the Stapplet to remind you the empirical rule. So let me go put the problem in. So here we go. Here's my next problem. All right, so what we're going to do is I'm going to go put up, I've got 85 and 20. So I'm going to set up 85 and 20 and plot the distribution. Now I actually don't need any calculation. It just created a nice little plot for me of what the empirical rule looks like. All right, so I'll copy that. So that's the empirical rule. So essentially, you have 1 standard deviation, 2 standard deviations, etc. So for this question, 99.7%. So that would be 3 standard deviations away, right? So looking at our work, that would be 1, 2, 3. So the answer is 3 standard deviations away. Huh? Come on. There we go. Mrs. Overman's having difficulty. There we go. All right. 99.7% is 3 standard deviations away. So 25 to 145. So when you do the Stapplet, it automatically shows, because here's your mean, right? There's your mean right there. And so then this is 99.7%. 99.7. Pretend Mrs. Overman can write with her mouse. There we go. So that's the empirical rule. So we'll put that in. And that was 25. Less than 65 millimeters. So we can go back. Less than 65 over here. So, let me copy the problem. So that one, you would probably want to have the filled in graph. I kind of have mine memorized, probably because I teach math. So I don't have it memorized. Well, you're allowed to write it on your cheat sheet, so it's not such a big deal. So less than 65, right? So less than 65 would basically be this area right here. I'm going to do a shortcut. So actually I have these memorized, so it doesn't matter. So you would basically say that first slice, if you were doing the empirical rule, you could say, oh, it's that 0.15% slice plus that 2.35% slice plus that 13.5% slice, which is 16%. Or you could do 50% minus a 34% slice, and guess what? You get 16%. So you're probably going, how'd you get that, Mrs. Overman? Well, I know right here is a halfway point, and if I subtract that 34 that's in there, so let me go ahead and label these. So we have the 0.15% is the outside slice, and it's easy to forget, right? And then you have the 2.35% slice is right here. Then we have the 13.5% slice right there. And then we have the 34% slice. Goes between these two markers. Remember, it goes between. It's not on a number. I know some of you were trying to write 2.35% on the number. It's actually the width of the slices. Okay, so good job there. Let's go ahead and go to the next question. I guess I'll have to, we said 16%. Someone has a blood pressure less than 80. So let's go take a quick look. Less than 80. Ooh, well, that's not a traditional one, so we're going to want to set up our Staplett, and luckily we do. So we go less than 80. So the other one was empirical rule. Oh, we want a calculate an area. Make sure. So I was on calculate a value, right? And you say, area. Well, no, I want 80. I want 80. So less than 80. Put in the 80. Calculate. And boom. The area is 0.4013. So we just put that in. There we go. Greater than 100, we go back to the normal distribution, and this time we say to the right of a value. We're going to put 100 in there and calculate the value again, and we get 0.226, which is something like that. All right, I guess it must have rounded. Yeah, 0.2266. All right, and we submit our answer. And they're all correct. Yay. Aren't you proud of yourself? Again, if you have any questions, I know I didn't really capture the scratch work for the last two. That's a lot like what we were doing up here. So it should be pretty straightforward. Feel free to bug me in class.